All right, let's talk about solving polynomial inequalities. So we have to solve the following polynomial inequality. I have x to the third minus 4x squared minus 15x plus 18, and this says less than 0. So it's saying this polynomial is less than 0. How I'm going to start off this problem is how I start many problems is let's take this entire polynomial, x to the third minus 4x squared plus 15x plus 18, and let's graph it. Okay, let's just see what's going on visually, and it's going to help us solve this problem. So I started by going to y equals in my calculator, type it all in, be careful how you type it in, make sure it's correct, and then graph it. Okay, now when you graph it, I would pay attention to the shape or just kind of know how degree leading coefficient affects shape. So I got an S that goes up, comes down, and goes up. What's especially key here is pay attention to where the x-intercepts are. So I'm going to draw just a pretty basic graph here. I had x-intercepts at -3, +1, and it looks like 2, 3, 4, 5, all the way over there at 6. So very basic graph, but it's going to help us out tremendously with graphing this. We went up, came down, went back up. So the graph is really going to be our key in being able to solve this polynomial inequality. So when it says this polynomial is less than 0, I just want to look at the graph that is considered less than 0. How that works is you're essentially going to use the x-axis here, because the x-axis is when y is 0. So we're trying to figure out when is this polynomial less than 0. Well, all parts of the polynomial that are less than 0 are below the x-axis. If this would have said greater than 0, then we worry about the top part. So I'm only concerned about the bottom part, so I'm going to use a note card here and only look at the bottom. What we need to do is we need to represent these two pieces here, okay? And if there's 3 pieces, 4 pieces, however many pieces are there, we need to represent these pieces because all of these pieces are solutions to these problems. So what I need to do is I need to write an inequality for this piece and write an inequality for this piece, okay? There's 2 different types of inequalities that we're going to write here. When you have an arch, either be a arch or a U, whatever you want to call it, a parabola piece, you're going to use a compound inequality. That's going to use 2 numbers with x in the middle, and we'll talk about that. When you only have a point and then it's going out, you just need a simple and basic inequality. So here's how it works. Things that we're going to need is we're obviously going to need x because the original equation needed x. If I'm going to write an inequality, I need a number for reference. The number that we're going to use for reference is the x-intercept. So this x-intercept was at -1, -2, -3. So all I got to figure out is what is the inequality that goes in the middle. Now there's 2 ways you could see this. You could kind of use knowing how inequalities work, and then there's a little bit of a shortcut. So if you notice, this point of the graph starts at -3 and then tails off to the left towards -infinity, or the smaller numbers, or the numbers smaller than -3. So it goes off to the left to the lower numbers. So I just needed an inequality that says, hey, I need the x's smaller than -3. So you'd use a less than symbol. That's kind of using just inequality logic. Now, if you kind of struggle with the inequalities, a little shortcut here is if you notice, this tail of the graph goes off into the left, where if you look at this inequality, it looks like an arrow pointing to the left. Okay, so that could kind of help you out. This graph's going to the left, looks like an arrow pointing to the left. So that's the first inequality to cover this piece. To represent an arch or use, we're going to need to use a compound inequality. So you notice my graph starts here at -1 and goes all the way up, or not -1, that's +1. +1 all the way to 6. My graph is between 1 and 6. Well, have yourself a compound inequality that goes from 1 to 6. So since my graph is in the middle, let's put x in the middle. Okay, I need the part of the graph that's bigger than 1, so 1 is less than x. And I need the part that's smaller than 6. X is less than 6. Shortcut here is the inequality. As long as you list the lower number and then the higher number, lower and then higher, the inequalities are always going to open towards the right. So what I did is I just represented the inequality on this piece, that's this guy right here, and I represented the inequality of this piece over here with this compound inequality. Both of these together are your solutions to this problem. Now, what does that mean? It means if you could pick a number that is less than -3 or a number that goes from 1 to 6, and if you plug it into this inequality, it's going to work as a solution. So all numbers less than -3 will work in this polynomial. All numbers between 1 and 6, so like your 2, 3, 4, 5, they are also all solutions here. Okay, that's what that means. So again, that is solving polynomial inequalities. If it's less than 0, you're looking at the bottom half. If it's greater than 0, you're looking at the top half, which would change our answers considerably here. And then you just write inequalities there. So like this would be a compound inequality. That would be a basic inequality. So pay attention to the top or bottom, pay attention to the x-intercepts, and you'll be able to solve polynomial inequalities.